Okay, so we're going to go through how to do a water budget today. That is a really important skill to those of us who work in Southern California. I would say have your pen, pencil, calculator ready. And you can see I've loaded a bunch of materials for you. The first item that relates to this lab is what I'm calling my zone map. So this is a typical residential landscape that I'm going to do a water budget for. There's some directions on the water budget lab. Take a look at that. I've got a section of the San Diego landscape standards. I pulled Appendix E out of the standards. And what this is the water budget worksheet. So if you were submitting to the city of San Diego, this is where you would go and get their process for submitting a water budget. Because we have lots of different jurisdictions or municipalities in our region, every city has a different process for doing this. The city of San Diego is a pretty good one to refer to. So we're going to refer to them. And then I've given you a little table that you can fill in to hopefully make this a little bit easier for you. So, definitely read through this landscape standards section. This will kind of help tie it together for you. It defines a lot of these characteristics like our estimated total water use. That's how much we expect our landscape to use. Kind of our evapotranspiration rate, that's how much our plants are sweating. Here's our adjustment factor for evapotranspiration, and that is utilizing irrigation efficiencies in conjunction with evapotranspiration. We have our hydrozones, so that's kind of what's defined here. But that again is our irrigation zones, and hopefully you've grouped plants by their water use and their exposure. An irrigation audit is something that is done to confirm these water budgets. So usually an independent consultant comes out and does an audit. Landscape area could be the entire premises or the area just for each zone. Maximum applied water allowance, that's our water budget. So basically what the city does is they make us calculate our maximum water budget. And then that we're not supposed to exceed that. So if you were submitting on a city project, you would want to make sure that your water budget worked out to be below this. For this class, I almost want you to play with the different types of equipment and different types of plants and see how those change in each of your hydrozones. So I'm not necessarily concerned that you hit your water budget. I'd rather see you play around with different combinations of plants and irrigation types to see how that changes the water use in each zone. So at the end, just give me a statement whether you've hit your water budget or not. And then our plant factor, and that's how much water, kind of the adjustment factor. So how much water each plant uses. So you can see very low, we usually use the 0.1 for low, usually 0.3. For moderate, I might use 0.5, high 0.7 to 1. This is water features in a lot of our lawn. Special landscape area, you get to use 1.0. So basically you get credit, not credit, it doesn't hurt you to have a special landscape area. So special landscape areas are areas used for active and passive recreation, areas solely dedicated to the production of fruits and vegetables, and areas irrigated with reclaimed water. Reclaimed is another word for recycled water. Today it's usually called recycled water. So that's water that's been repolished and reused. So none of those activities ding your water budget or make it harder to meet a water budget. And you notice areas used for active and passive recreation. So that a lot of times is lawn. So if you're using lawn and it has a designated recreational purpose, you actually don't get hurt by this water budget process. If you have lawn that is not serving an active or recreation use, then this water budget starts to really hurt your ability to meet your water budget. So older, maybe industrial or commercial developments, you would see lawn being used in the parkways, like for, miles. We don't do that anymore because we can't hit our water budget. And no one's going to go out into a parkway in an industrial area and play ball, right? So it's not serving any kind of recreational purpose. So the first step is to create a water budget. That's the overall water allocated to the site that you have to design to. And we'll go through that part together. And so here again is some definition of defining these different terms, because you can see there's formulas that we get to use. So we'll be working through some of those. I'll get you started with this. There's an Eto map. So that's how much water is being used in each area of the region. In the original documents, it's in color, but I didn't print it in color because there's also a chart and I wanted to save my color ink. So on our site, we have set it in Otay Mesa. So Otay Mesa proper at 47 ETO per year. So to keep a cool season turf growing in Otay Mesa, you would have to irrigate 47 inches per year. That's what these numbers mean. And then some more definitions, a similar chart. I filled in some of the data. I want a little bit different data than they require, but you got some basic data here. So here we've got all of our zones on your chart, on your table that match this map zone. So this is kind of a visual reference, but you can see zones 1 through 11 have been pulled onto this table. They all have the same zone because they're all located in Otay Mesa where we're at. Each one of them has a different hydrozone, and that's our total project area is 4,835 square feet of landscape area. And then each zone makes up a part of that. And then I've done the first one for you, and we'll get into this calculation. And that will get you started, and you can do the other 10 zones. All right. So the first thing we want to do is we want to figure out what is our MAWA, or our maximum applied water use, right? So we know that we have this many square feet in our total landscape, and we go back to that formula that is in our appendix of landscape standards. And we want to do step 2, determine our water budget. So we would say our MAWA is equal to our ETO, and then times 0.62. This is just a conversion to gallons. And then we've got kind of a little bit of a graphic here, ETAF times landscape area plus, we're not going to do any, we won't do any special landscape areas, but if we did, that's how we would do it. And that basically gives us our credit back. So we're going to simplify this, and we're just going to keep it at that. So now you can see here that we have different evapotranspiration factors, right? Area factors. We have one for residential landscape areas. So we have a coefficient of 0.55. And then for non-residential, we have 0.45. What that means is we have a little bit more water to use for residential projects than we do for non-residential. So this is a residential project, so we will be using the 0.55. And here's some breakdown of those numbers, right? So we've got our ETO. We said we're going to use the Otay Mesa ETO. I've already moved it up onto this chart. So that's 47. Then we have this conversion, 0.62. That's just converting to gallons. And then we have this, ETAF is 0.55 for residential times our landscape area is 4835, right, square feet. Okay, so we can just do the math a little bit. I like to kind of work my way through these brackets and just solve for what's in it. So 0.55 times 4835 equals 659.25. Right, so I've got that. Okay, got that. Merge that down. I do the same thing with this. 47 times 0.62 is equal to 29.14. I'm going to times those together. Times 2.914, 2659.25 is equal to 77,000 gallons, 490. I'm going to round up 449.1 gallons per year. So that's my MAWA. So we do that calculation, right? So kind of walk that through together. This is your water budget for the project, for this amount of landscape area, the fact that it's located in Otay Mesa, the fact that it's a residential project. Those are all factors of influencing that number. So now to determine our water budget, we have to do a similar calculation for each and every one of these different zones. So on what I want you to do is I want you to pick a representative plant for each zone. So if I look at zone 1, which is right here, here's my zone 1, 405 square feet. I've chosen lavender. Now I'm going to have to look up lavender. If I don't know, and you should always verify, I've given you a link to Wookles online. Let's see if I can go to that. Yes, I do. I've given you this link to this Wookles site. So this is kind of a shortcut just to the plant database. So if I have a particular plant in mind, like lavender, the way I'd search for it is I would look for my city. So let's see if they have Otay. If not, we'll use San Diego. We do not have Otay. So we'll go right to San Diego. Okay. And that's going to give me my region. I could also pick from a map. And I'm going to say lavender. So you can Google by botanic name or common name. And I'm going to search for plants. Think about it a minute. So here's my lavandula lavender species and cultivars. So in San Diego, which is a south coastal region, lavender is a low water use, and I've designated it there. So if you're researching plants, then, and you don't know plants, maybe you haven't taken plant ID, not your thing. Say I want to research a very low water plant or a moderate water plant to play with this, and I don't know plants, I still would start with my San Diego city, right? And I could say, okay, for zone 2, that's kind of like a ground cover area. So I want to search ground covers, and maybe I want them to be moderate. Maybe I want that a little bit more lush and green and not so dry and gray and crispy. So I might search my plants that are suitable to San Diego. Now it's going to pull out all these moderate plants that might make an appropriate ground cover. So I could say, oh, maybe I'm going to, let's see, what's a good one? I really like Fragaria. So that's a sand strawberry. So I might choose that to be almost like a turf replacement ground cover. Now I could choose turf if I wanted to on this project. There's nothing, you could add turf to one of those areas. Maybe in the back I would add turf, but in the zone 2, I could say I'm going to choose this sand strawberry, which is a native plant, and it makes a nice green turf-like plane of planting. So that's how I would use this to help me search for plants in addition to finding out what the water use of plants are. So hopefully that helps. I've given you a link to this in this class module. There's a link to this WCALS 4. And there's also a printout of the entire huge WCALS 4 that walks you through all kinds of calculations for those of you who are really wanting to understand this better. Okay, so I'm going to stop this share and go back to my camera. And now you know how I got the low water use. Now in the water budget lab, I've given you some parameters. You can choose from, for plant factors, I've given you what I want you to use. So that you can use very low, low, medium, or high. And I've given you cool season turf and warm season turf. These are pretty typical to what we use in the industry. The city of San Diego, at least in this version, gives you a range. So they give the designer a little bit of freedom to make that call. These are pretty typical. This is what you would see with some of the LEED certifications. So you can see lavender is a low water use plant, and I have a plant factor of 0.3. And then on that plant, I'm going to use a drip irrigation. And so when I look at my irrigation efficiency, well, my choice is I either have drip or overhead spray. And this is pretty typical to most of these guidelines at this point. There was a big revision to these in 2016, and cities tended to simplify by saying it's either drip or overhead spray. Part of the problem of this is overhead spray that is a low precipitation overhead spray, like the newer MP rotators, is about a 0.75. However, if you have old conventional sprays, like a lot of sites do, it's actually much, much lower. The efficiency is maybe 0.55. But for the sake of this exercise, we're going to use one of these two because that's what the city requires. You have to pick one of those two. Okay, so if we go back to this, it walks you through how to determine the estimated total water use. And the way that we do that is each and every hydrozone, we run this same calculation over and over. So you can see when they walk you through that, they only give you two choices for irrigation efficiency, 0.81 for drip or 0.75 for overhead spray. Okay, so in this case, I have chosen drip irrigation at 0.81. When I do that calculation, I end up with 5,390.9 gallons per year. So let's go through that together. I do recommend that you show your work for each hydrozone and for the MAWA. Now I'll grade you depending on how it looks. But if you've gone really awry somewhere and you haven't shown your work, I can't figure out where you've made a mistake. So show your work. Okay, so we're going to determine the total estimated water use. Again, we're not working with an SLA. So we're going to set this up. So this is zone 1, right? We want, and here's our formula, the estimated total water use equal to our ETO. So that doesn't change from the MAWA calculations. We are not moving our site. The coefficient to gallons does not change. So there's our first part. And then we can have our plant factor over our irrigation efficiency times our hydrozone area over our irrigation efficiency. And then we don't have an SLA, so you can ignore the last part of that formula. So for zone 1, our estimated total water use is equal to, we have this first part, well, let's just fill it out like this. 47 for OTI, right? Times 0.62. And then our plant factor was 0.3 over our irrigation efficiency was 0.81 for drip times our hydrozone area, which was 405 over our irrigation efficiency, right? So there's our formula. So we'll do this first one first, and this is going to be unchanged from the MAWA, right? We did the 47 times 0.62 is equal to 29.14, right, in that first part. And then this one, we can do this in stages, right? 0.3 divided by 0.81 is equal to 0.37. I'm going to say 0.4. I'm going to round up at some point because I've got a longer thread there. Times 405 divided by 0.81 is equal to 328.05. Right, so then I can do that times 0.3704 equal to 121.50972. Okay, so I take that number times the 29.14 is equal to a different number than what we have, and I'm not sure why that is. Why did that happen? Let me see why I think, no, I'm not quite sure. Hold on a second. Okay, I took a quick look and I must have made a keystroke. Okay, I took a quick look and I must have made some kind of a keystroke error over in this portion right here. Because when I reran it, I ended up with 405 divided by 0.81 is equal to 500, not 328.05. So when I use that, 0.3704 equals, got now this is 185.2 times this 29.14 is equal to 5396.73. So I think there's a slight difference here because remember I shortened this number. So I think if you use the full numbers and you do your math properly, you'll end up with a number like that. So we are close, and so sorry to confuse you there, but that's how you get this number along this edge, right? So I've done the first one for you. So we did collectively this MAWA calculation, and then collectively we did this one for zone 1. So what you're going to do for zones 2 through 11 is you're going to pick a representative plant for each region. You could, I don't necessarily need to see that on the plan, but if you want to keep track of it, you could write it down there. And then you're going to look up the Wiggles plant rating. You're going to reference the plant factor from this instruction sheet, right? So right here. And you can see for this one, because it was a low water use, that means 0.3. You're going to select an irrigation type and list it. So you're either going to choose from drip or overhead spray and put the associated efficiency in there, and then run this estimated total water use calculation for each zone as you go down through. So you'll have the hydrozone area changes, but obviously the project's located in the same site. So the ETO does not change. And then what you're going to do at the end is you're going to add all of these up at the bottom, and you're going to compare your total gallons per year. So it wouldn't be this, that's just for that zone. There must have been an add thing in there. You're going to total those up, and you're going to bring this over 77,491. And then you're going to figure out if you're above or below water budget for your site. So that's it, a bit of math tonight, but it's pretty basic math. And this is a really important skill to do these water budgets. These are pretty much required on anything that needs to be submitted to the city. So I've tried to give you some city criteria to work with. So have fun at it, get proficient at it, and that will be a real world skill that you can put to use. All right, that's it. Good night, everyone.